All right, about another minute and then we'll talk, okay? Sorry, I should have made this bigger on the screen for you guys. I apologize. And of course, now if I make it bigger, it'll mess up my drawings, I think, but I don't want to risk it. Well, I can. It's actually not that bad. Oh, except that one. Whoa. Okay, let's go ahead and talk. Hopefully, these ones should have felt easier, right? The functions weren't too hard. Hopefully, right? So for number 8, what are our 3 outputs? So for if our function is x plus 7, when x is 3, what is our function of x? Yep. Yep, thank you. How about when x is 0? What is our function of x? 7, good. And then how about -2? Not negative, positive, right? We have +7, -2. So, right, it'll stay positive. It's just we're moving 2. So it's like subtraction. It's like a subtraction problem, but backward, right? -2 plus 7 is the same as 7 minus 2. It's just. Okay, good. How about for number 9? So now we have x minus 2. So when x is 3, what is our function of x? 1. And how about if it's 0? -2, right? Yeah, good. And then how about if it's -2? It's going to be actually negative, right? Because you have -2 minus 2. So you're going to keep going that way. I mean, and we kind of were doing this on Monday, right? So I mean, I'm always thinking about the number line, right? So you can always take your first value, right? Which would be like -2, and then look at the next piece, right? And if it's -2 minus 2, then you know you're going 2 more to the left. So yeah, it is. I mean, I don't know, like, yeah, I don't know like an easy trick, but hopefully if you just keep seeing it. And so just thinking of those signs as either a movement one direction or the other. So kind of find the first point on the number line and then decide, am I moving this way or this way? And then where you end up, it should be right. But yeah, it's definitely not easy. Okay, so now our function is 3x. So when x is 3, what's our function? 9. And if x is 0, what's our function? Yeah. And how about -2? Okay, so hopefully everyone's feeling like this is easy peasy lemon squeezy for the most part. Cool. How about 11? Now our function is 4x minus 1. So what is our function of x if x equals 3? Good. And if x is 0? -1, right? Yeah. And if it's -2? Yep. Good. Please, anyone stop, ask questions if you're feeling lost or confused. All right, last one. Here we have 1.2x. Now, decimals are a little funky, but you might still know your 12s times tables, maybe, right? And then you just know to put, right, put a decimal place one space over, right? So if our function is 1.2x, what's our output if x is 3? Yep. Right? 12 times 3 is 36, but since we have this decimal, we just, right, move it one place to the left. Good. How about 0? Yep, easy. And then what about my -2? There you go. Yep, good. All right. How's everyone doing? I want to check in one final time. Amanda, are you doing all right? Great. Okay. Cool. All right. Well, I think we're at a good spot now that we're all warmed up. Let's go ahead and take a little break. We'll take about a 10-minute break. And yeah, so we'll take a break till about 5 till 2. And then we'll get back into our chapter, okay? So I just always want to kind of review and make sure that everyone feels like you're getting enough practice before we continue and do more complex things. So awesome. Okay. Yeah. You got your GED. Yeah. Yeah. It's 3 points above the passing score, so it could be a little higher, but you know, what you can do as well, if you want, is you can click that and I can give you some targeted pages based on what this test is saying you need to study more. So we're going down. Yeah, and then if you just write those page numbers down for me. Or I can write them. But yeah, to screenshots. Yeah, sometimes it. All right. So yeah, then to screenshot it, did you already submit them? Okay. Okay, so go back up. Oh, okay.
I think I wanna like.
Okay, no
Because
worries.
I just should have asked that before.
Oh, yeah, no, you're good. So, it depends on your goals mostly, but 145 is passing. And so, I've definitely seen people with that green score pass the actual test, but yeah, so what you can do, Tevin, is I can print out these pages for you, and if you want to work on them independently. So still coming to class and getting your hours and stuff, but if you wanted to focus on this more independently, as long as it's not distracting me in here while I'm teaching, you can have headphones on or whatever, then yeah, you can kind of be on your own path. If that works for you.
I have a question.
Sure.
Is it like, are we like 250?
Oh, yeah, no, definitely. Definitely doesn't bother me at all. Yeah, and just remember when you sign in, you can put 250 as your timeout next time. It's no big deal though.
Okay.
It's 10 minutes. I'm not too worried about it. But yeah, so if that might be a good plan, if that sounds like a good plan to you, Kevin, I can do that here. Oh.
And like,
Mhm.
like if you were like. Based off of the scores, right? Like.
Yeah.
Scores of, the kind
Mhm.
of greater it makes.
Yeah, it's easier to get accepted into colleges if you have a little bit of a higher score. But like for community colleges, which is a really good starting point, I mean, oftentimes we encourage students, like, if you still want to go to a four-year university, you can do your first 2 years here and then transfer, and it generally seems to be a lot better for most students. So yeah, so the what GED says is the college ready score is 165. So yeah, no, you just have to pass.
Okay, gotcha.
Just need to show that you passed all 5 of the tests and that you have the high school diploma.
Yeah, I wanted to go here too.
Perfect. Yeah.
College.
Yeah, luckily there's no like set score that you.
All right, that's.
Yeah.
Thanks. Yeah. Do you have like different clients?
Yeah, I'm trained at all the houses, so.
I used to do that too.
Oh, really?
Yeah, before, like. I was with it for like almost 2 years.
Quality?
Yeah, no, not the quality, with a whole different care system, but. Thing. I mostly work with like elderly and kids with disabilities. So. Not with the same, like the same program, but I do the job, it's just like, I only was there for like 2 years. Like one of the people I used to work for passed away. And so I just felt like I couldn't do that job anymore.
It's comfortable with some of them too.
Yes. I really felt like you get really connected to them. So after she traveled, I was like, oh, I think I want this.
Looking for a second job though, because. Oh, we went off in the word. Boy. So. I'm probably the youngest person there.
Yeah.
Like today, I have to make myself come in. It's cool with a lot of knowledge, like everything.
Yeah. I made it up to my 12th grade too, and honestly, I was only lacking like half the credit in algebra already. Because I went to like charter schools, so I didn't actually go to high school, so I charter schools and I just taught Kind of sad that I'm only missing half the credit in like a company here, but this really does work. Like, like it really does. And like I said, I've only taken this class, it's not just one. Scores like lit up, just like that.
Yeah,
Yeah,
these are my scores were pretty good,
yeah.
but I'll just take the classes just to see, like, everything's just going over and what I remember.
Yeah,
I'm pretty strong with math,
me too.
like reading.
I know, right? I like the English class too. I'm only doing the English and math. Like, it's good. It's good. I mean, if the score says I'm very young, I just want to learn this stuff and probably study science.
Oh, yeah, I'm doing some studies there, yeah. Only because Pat said that these two are the main ones that I should just try and bump out.
How's the social studies? Is it,
I was supposed to go yesterday, but I got sick, so
Yeah.
I'm gonna put that in.
who teaches that class?
I think volume. Only an hour and 15 minutes, so.
But yeah, I want to test out and see if this is pretty good. I mean, if they accept their scores like this here, because I want to come back here for like community college. I don't think I'm ready. I could start here, that'd be cool. So it just makes job, you know, like doing the job.
All they do is talk about me unless the other one's working. So many times when they're calling me in, they're calling me when they're drunk, say that they can't. Argue with the clients, they fight with them and stuff, so I probably put my foot down and to the boss, and she was mad about everything, she was like, I'm moving to the house, but because of that, I'm only 34 now.
Yeah.
My friend told me to try Tumblr, like for part-time.
Yeah.
Full-time there, and part-time when I work,
Yeah.
because. Probably fun.
I thought about doing that. I worked at Fashion, like we worked with bakery with Nel. So like, I mean, we're really short on staff. Like I was only supposed to be part-time, but like I get full hours. You know?
Like, you know. But I'm good with them. Just with those.
Yeah. Right now, like my boss is hiring me to go out just yesterday, and I was getting. But he's very picky, like, he's picky about like who he chooses because he wants someone who's reliable.
Yeah.
Like a lot of people are like, they just like come in, you know. They quit or they show up. And it's just like all these no calls and no shows are like messing up.
I think
Because
that.
even people on their days off, they're not supposed to be working, they're actually working.
What's the store number to them?
Zeros. Oh, I don't know. Let me see.
Because like I can apply, because like, it's. I worked at Safeway. And
Or yeah, but yeah, you can try. Just put your application in and then
the store number, because, I know some of these things, they ask for, what's the store number,
like the actual telephone number or like the store number.
like the number, like maybe like 8.
It's stores 067.
067,
Yeah.
looks like.
Cause like I said, he is hiring and like, I don't think, I mean, all the people so far who who like do their interviews, he was just like, no, I can't do it, like, you're just, I just am like very picky and I want to stick it out, cause like that job is really demanding and it's a lot of work, but it's good though. But yeah, they are, I don't know if they still. Standing on Monday. You know, it's really job interviews. And supposedly one's like guaranteed because we have 2 people leaving that department and they're moving to different. So just because they're freaking tired of all the work and just, they're like, man, I'm starting to hate my job.
Girl never up with. Depends on where you look for. They sort of fashion.
Me too. Me too. What's your name? Amanda. All right. Well, if he mentions it, because we always talk about like, he's always like, oh. Hey, that goes.
All right, I had some of them. I didn't have all of them yet, but there's a start for you. Oh, yeah, but yeah, definitely. Okay. Well, I gave you guys an extra 5 minutes. Bonus 5-minute break. All right. I knew I was gonna take longer. Okay. All right, and we lost Teresa. Hopefully she'll be all right. Okay, let's go back to our lesson. Maybe. So we are in our big basic algebra packet, and I think everyone has it. 8th, it's still the one that we were on when you were able to join us this summer. Okay, so. Okay, so. Hopefully I'm sharing the screen, the correct screen. All right, so hopefully everyone still has this packet that we've been working on, and we are on page 25. We're working through all of these function questions. So we did number 11 today, or last Monday, goodness gracious, today. I don't know, I was sick. How's that for instance? Okay, so hopefully everyone feels good about what you're going to need to do here. So just to kind of review and remind us where we're at. So you're going to see a problem, and this is very similar to what we did. It's just, of course, way more complex because I don't know why, but I like the materials, but sometimes the questions are really complex. But right, here's our function right here. And then we have five values for G that we're going to plug in, right, to get our output. Once we have our input and our output, right, that gives us what we would call, right, our points that we put on the coordinate graph. Okay. Does everyone feel good about putting points on the graph? So, and hopefully, because this is gonna be what we're gonna be doing for a while, so I'm sure we'll get lots of practice, of course. All right. So remember that a point on the graph, right, it's gonna start with an X coordinate. Oops, cannot see that color. Try again. So, right, you always have an X coordinate first, and then your Y coordinate is second, right? So you find your coordinate on the horizontal, right? And that becomes the first part of the coordinate point, right? And then the vertical is the second part. So for example, right, if we look at this point here, Where is it on our X? It's at -3, right? Which is what we have up here, right? So this point here, we would write as -3. And then where is it horizontally? It's also at, this is -3 though. Yep. Okay. So in the coordinate graph, right, we have what are called, like there's 4 quadrants in the graph, right? So there's like positive, positive, right? So here, right, if your points are positive, they'll be in this quarter of the plane, right? This opposite end, right, is our negative, negative, and then up here, right, we have -x, positive y, and then this side, right, it's reversed. We have positive, whoops, positive x, negative y, okay? And so yeah, so if you saw this question on a progress test or the GED test, and you'll definitely see this, right? So just like we did, right, you take your inputs, put them into the function to get your output, which is your y coordinate, right? And then, right, where your x and y meet become, right, your points. Okay, so I just want to make sure everyone feels okay about being able to put points correctly, right, based on their coordinates onto the graph. Does everyone feel good about that? Hopefully, cool. So yeah, so you'll always have the horizontal coordinate followed by the vertical. Where they meet is the point. Okay, so number 12 is something that we haven't quite looked at yet, but I think we can at least talk about it. Oh, so what's one thing you notice about this problem that looks different from the other problems that we were working on? Yeah, exactly. Good, good. Yeah. So, right, like for example, here, right, our line is, it has little arrows on both sides, right? So it's a line. And if you know the fancy geometric definition of a line, right, you basically imagine the lines extending both directions forever, right? It's just going on and on and on. And that's what our regular function does, right? And so the other thing that makes it different, right, is that when we have this like full line or this like continuous line, right, we're using the equal sign to talk about, right, the function and the input and the output. But if you look here, right, now we see not equal signs, but something else. Do you guys recognize these signs? I know it's kind of small on the screen. This is page 25. So, right, this is a less than or equals to, right? This is greater than or equal to. So we've talked about this a little bit, and hopefully this isn't too horribly confusing, but sorry, stop myself and keep going now. Okay. Yeah, so when we look at the graph, right, and we look at where, right, and so yeah, right, this is a point here. So it's like the line, this is what we would call a vector, which just means that the line has a starting point and then, right, it just flies out into oblivion, okay? And now you guys know the fancy word vector. It's more helpful in science than, well, it's helpful in other things. Anyway, so yeah, so when we think about how inequalities look compared to our equations, right? Equation, equal sign, inequality means we have these greater than, less than, greater than or equal to, less than. Okay, so yeah, so this is showing us, right, that basically it starts from here and then basically is kind of encompassing everything around it. So before I get too excited, I have to check one thing. Oh, I'm sorry, I went too far. Okay. So, yeah. All right. So it's asking us the domain of the function is blank. Okay. So when they use domain, and like I said, this is just more ways to talk and think about this. So domain is our X and the range is our Y. Okay. So all we need to do to solve this, let me zoom out a little bit. Okay, is really just what's the X coordinate of that point? Good. Okay. So if we look at our answers then, right, we know that the X is either going to be A or C. So now we have to think about, okay, is this line showing? And remember the X is basically the solid part of the line. So we start at -3 and then are the values of X larger than -3 or smaller than like -3 based on the direction of the line? Larger. Good. So does A show us X is greater than or equal to, or is C showing greater than or equal to? C. Okay. Good. Uh-huh. Oh. No worries.
Yeah, I'm gonna figure out when you will. Oh, yeah, I'm so sorry about that.
No worries, no worries. I know I'm kind of the paper packet queen, so I give you lots of papers. All right. So hopefully, I mean, we're going to work on inequalities more because we're going to have to deal with them more, but this is a good starting point. So the solid dot means greater than or equal to. If it was an open dot or like a circle dot like this, then it's either greater than or less than. But if it's solid, it's either greater than or equal to or less than or equal to. So yeah, so really this is just saying, where does the line start? So you look for where is the point, what's the coordinate of the point, and then the domain is the X. And then what would we say for Y? Is Y less than or equal to +4? Is the Y value getting higher or lower? Lower. So do we want to say A or D? Y is greater than or equal to 4? A. Good. And does everyone, so when you read an inequality, right, you're reading from left to right. So if your less than or equal to sign is open, right, it's always open toward the greater quantity. Okay. So yeah, right here, Y is less than or equal to 4. Here, Y is greater than or equal to 4. So good. So you just, yeah, find where the vector starts. And then, yeah, you look and you say, okay, this line, the X values are increasing, but the Y values are decreasing. And hopefully that visually makes sense to everyone, because yeah, we're going to move into this kind of piece of algebra where there's this kind of visual graphing component. and a math component. And so we have to learn to kind of see this stuff in a good way, okay? All right. All right. Number 14 was something that we talked about before we started class on Monday. So you guys might not know this, but here, okay, Genesis, the table below represents a function. Martin says that it doesn't, okay? And so what we can see here is, right, that we have 4 different inputs, but for each input, we're getting the same output. So do you think, does anyone remember, maybe Lauren or Curtis? It's okay if you don't though. Is this a function and how would we know? And so let's go back. If we go back to page 22. Oh, okay. So, sorry. Sorry. Okay. So what we learn is that, right, if you have 2 of the same inputs, then it's not a function, right? Because you're inputting 2 of the same things. But you can, let me see if I have an example of that. Well, if you look here at any of these other examples, right? So the only thing that makes something not a function is what we were saying. If you have 2 of the same inputs, okay? So you can kind of see here, right, that this is what makes something not a function, okay? So when we look at Jenna's table, is it a function? So we have 2 of the same inputs. It is a function, as far as I know. Yeah. Yep. As long as none of the inputs repeats. Yeah, it's okay if you get the same output. It just can't be the same input. Yep. And it probably means you have kind of a funky function, but that's all right. Or there must be a 0 somewhere in your function that, yeah, making all of your output 0. Okay. All right, so let's look at number 14. Go ahead and read it. See if you can figure out the answer, okay? And remember, maybe I gave you guys the answer too quickly. Did you guys get an answer for 14? Or are you still reading and thinking? So if H, right, if H of -4 equals 6, what do we know to be true of the information we're given? Okay, so for number 14, hopefully everyone chose A, right, for your answer. Okay, and remember that when you see your function notation, right, the part inside the parentheses is your X, your input, right? And then whatever the function equals, right, is the output. So this is your X, this is your Y. So what do we know is true? We know that the point -4, 6 lies on the graph of Y equals H of X. Don't worry too much about this fancy word, but it's just saying, right, that the line that this function makes, because we don't even know what the function is, right? They didn't need to show us that because they already gave us an input and an output. I mean, I guess we could have fun and make a function, but who wants to do that? All right. Any questions? Everyone feeling okay about function notation and knowing what to do with it? Mhm. Oh, yeah. So it's just because that F instead of the H. No, you can change this. F of X is the most common. But yeah, you can use, once again, just like any variable, you can make this variable any variable too. It's just generally they choose F because F for function, as far as I know, although I probably should ask Google for sure, the F of X, the F equals function, but yeah. So it's really just saying that this is, this is just anything with one variable and then the parentheses of the variable inside of it next to it is signaling that it's a function. So you know that what goes when you plug in when you plug in a value for X, right, you should do something to get a Y. Yeah. Oh yeah. Forgot to write my answer here. So yeah, and the only thing, and you might see a question, right, that might do this kind of trickery testing, right? So yeah, you might see a question like that, right? You might get a chart like this. Is it a function? Well, if you have your unique inputs, yes. If the inputs are repeated, no. Okay. Because hopefully it makes sense, right? That for each unique input, well, every time you put in the same input, you should get the same output. So if you aren't, then there's something wrong. Right. And you don't need to, you don't need to input 3 again into the machine because it already told us, right, the relationship of the function or the output to the input value 3. Okay. Any other questions? That was a good question. So yeah, it's really just a matter of recognizing this notation and knowing what it's kind of wanting you to do. So you're always going to have some kind of input and some kind of output based on the function that you're given. So, okay. All right. We've got good time. All right. Get in there, guys. Okay. So we're going to continue with this idea of functions and especially what we call, linear functions. And so we're going to be working, sorry. Like I said, we're going to be working with our coordinate plane. We're going to now have kind of 2 pieces to work with. Wow. How sensitive that is. I can do 1. Oh. Okay. So we have this concept now, okay, when we have an input and an output that, and I think we've kind of touched on this, but we're going to look at this concept of rate of change and slope, okay? And so, of course, the first thing to remember is now we're talking about specifically about linear functions. So these are our functions that create those straight lines that we were seeing on our last set of practice problems, okay? So we're always now, well, not always, we're going to move into this idea of linear equations, and linear equations allow us to draw lines in our coordinate plane, okay? And each line has an equation, and you can think of that equation as a function, right? Because the equation's usually y equals something, okay? So you usually have an x value to solve for the y value, okay? So the rate of change of a linear equation is the slope, okay? The slope of the graph of the equation, okay? So slope is going to be something that we're going to talk about a lot, okay? Slope is defined as the ratio of the rise or the vertical change to the run or the horizontal change, okay? So it's like, once again, we always kind of have 2 pieces that we're dealing with, okay? So you can think of slope as rise divided by run, okay? And once again, right, rise is the vertical change. Now you can, it's not always just rising, right? It can descend, or I'm like, what's the opposite of rising? Falling? Yeah, I guess it can fall. You can have a falling slope, okay? But yeah, so you're thinking of the rise over the run, or the change in y divided by the change in x, okay? And the other important thing to know about slope, and we're going to see this here, is that, and once again, you know, gotta love algebra, they represent slope with m. And this is one I should talk to Google about because I have no idea who chose this. But now, okay, when we're talking about linear algebra, whenever you see this m, we're talking about the slope, okay? And so a linear graph or table that includes the points y1, x1, and y1, x2, and y2. So basically, if you have your line, you just need to locate 2 points on the line. And it doesn't matter which point you call x1, y1, and which point you call x2, y2. But we can practice and kind of see which ones might be better to call what, but, right? So this is 1 point on the line. This is another point on the line, okay? And once again, it doesn't, I mean, you can choose any points that you want on the line, right? Let me know if this isn't making sense, okay? All right. So in order to figure out the slope, we have to know at least 2 points on the line. Okay, if we don't know 2 points, I don't know, they're messing with us and not giving us enough information to solve the question. Okay, so we have to know 2 points. Okay, and then to calculate the slope, we use this formula. Okay, so just like it says here, right? The change in y. So we take our second y point and subtract it from the first. And then we do the same thing with x, and then, right, whatever, once we subtract, then we divide. Okay. And we're going to look at some examples here. So hopefully no one's feeling too lost yet. Okay. And yeah, here, once again, it's not telling us, it doesn't matter which point we call point 1 and which point we call point 2. As long as you can keep them straight, it really doesn't matter, okay? In a linear equation, the slope is the coefficient of the independent variable, usually x. Don't worry about that sentence yet. We'll talk about it here in a second, okay? All right. A graph with positive slope is increasing in value. And it rises from left to right, okay? And that makes sense, right? Because we're going from negative to positive, okay? A greater slope means a steeper line, okay? And so this is the other thing. So slope shows us 2 things. Positive or negative tells us the direction of the line. Are we increasing or decreasing? And then if the slope is a large number, then that is really steep, right? It's like approaching vertical, right? Whereas if it has a very small slope or a very small slope, right? It's only rising slowly, okay? So let's get all these pieces straight. Because once again, right, we should get used to being able to just look at a line and at least be able to say, is there a positive or negative slope? Does it seem to have a really steep or great slope, or does it have kind of a gradual slope, which means it's smaller, okay? And then of course, the opposite is true for negative slope, okay? Now we're decreasing in value. We're going from right to left, okay? And then, right, a lesser slope. Oh, wait. Oh, okay. This is a little confusing, but once again, right? And so slope tells us direction and steepness, okay? Okay, trying to decide what I want to do here. So yeah. So it tells us the direction and the steepness of the line, okay? So once again, direction is determined by whether the slope is positive or negative. And then the steepness, right, depends on the value of the slope. It doesn't matter if it's positive or negative, but if it's like, if it's a slope of 4 versus a slope of 1, right, that slope of 4 is going to be way steeper. And why is that? Because we're going up, we're rising 4, but only running 1, right? So you rise and then run, rise and then run. So if you're going up 4 and only over 1, right, your line is going to be very steep, like this one. Okay. Right, this line has a positive slope, right? It's going upward from left to right. And then hopefully you can just kind of tell, right, from looking at it, like, wow, this is a steep line, right? It's going up very quickly. Whereas, right, if we look in contrast, D, still a positive slope, right? But it's just a smaller slope, right? It's less steep, right? Which hill do you want to climb? Do you want to climb that hill or do you want to climb this hill? Or none? Okay. All right. Okay. So we have our formula to calculate slope. Okay. So here's what we're going to work on. Okay. So here it tells us which of the following does not have a slope of 3. Okay. So the first choice that we see here is A. Okay. And so this is our, sorry, check and make sure. Okay. This is what's called the slope intercept form. And so this is an equation for a line. Okay. And you might have heard of this before, but oftentimes this is shown as y equals mx plus b. Okay. And so remember, right? M is slope. And so if we need to know the slope of the line and we have this form, we just look at whatever number is attached to the x, okay? So we know that the slope of this line is 3 because of the form that it's in, and we can just trust that, okay? So we can say yes, right? A does have a slope of 3, okay? In choice B, okay, these are points, right? So they give us 4 different points on the line, right? The first point is 0, 1. The first point is 1, 4, right? And so what we can do is choose 2 points. I'm going to choose this point and this point, okay? So I'm going to call this first point x1, y1, and I'm going to call this other one x2, y2, okay? Then I'm going to use this formula, y2 minus y1, so y2 minus y1 divided by x2 minus x1, okay? And then I do my subtraction first, which I know goes against what we practiced on Monday, but just trust me if that works for everyone. So 7 minus 4 is 3. 2 minus 1 is 1. So 3 over 1, which is the same as 3. So yes, right? These sets of points or this line also has a slope of 3. And right, I calculated it using 2 points and my slope formula. Does everyone feel like you could find the slope if you're given some points? And we'll practice this, so don't feel, but hopefully that process makes sense, okay? They've given me points. Okay, so if I need to figure out the slope, I choose 2 of them, plug them into my formula, and that'll calculate the slope for me, okay? So then we would do the same thing for C, right? They've given us 2 points again, but of course here, we have to write them out for ourselves, right? So this point here is 1, 2. So. And then our other point is 0, -1. So then, right, I found 2 points. So now I can go back to my point slope form. Okay, now. So like I said, it doesn't matter what you call, like what you call x1, y1 and x2, y2, but because we're subtracting the second point from the first point, I always try to make the larger points my x2 and y2, just because it'll be easier in the formula. So I'm going to call this point x2, y2, and I'm going to call this one x1, y1. Okay. So then, right, I go back to my formula up here. So y2 minus y1 divided by x2 minus x1. Okay. Does everyone see how I took my 2 points, I named them, and then I plug them into my formula? Does everyone feel like that is doable and makes sense? Okay, so then remember here, right, if you have minus a minus, it becomes positive, okay? All right, because we have 2 minus -1, so it's the same as 2 plus 1. And then 0 minus, or 1 minus 0 is 1. So yes, right? So once again, we know that this line has a slope of 1, okay? And a slope of 3, okay? 3 over 1 is the same as 3. So yes, this line's slope is 3, okay? Now, what do you guys think? Is this line also have a slope of 3? Do we need to do all of our fancy calculations to confirm? No. Because if it had a slope of 3, right, it would be shaped like this line. And it's way less steep, right? So I think we wouldn't even need to check, right? Yeah. So yes. So choice D actually has the opposite, right? It has a slope of 1/3 as opposed to a slope of 3. And 1/3 smaller than 3. So if it's a slope of 1/3, then it's definitely less steep. So it's like, if we know this one is got a slope of 3, you should just be able to look at this line and be like, it's definitely not as steep as that line. So, you know, if all you're concerned about is it have this slope, well, no. Okay. All right. So cool. Okay. So example number 2, which has a steeper slope, the graph of y equals -9x or the graph of -2x. Good. Yeah. And right, it's just because, right, even though -9 is less than, right, we think about what we call absolute value, right? 9 is always more than 2, and it doesn't matter, right? The negative sign is only telling us the direction, and it's the number of the slope that tells us the steepness. And it doesn't matter if it's positive or negative. If it was, even if it had a slope of -9 versus a slope of +2, like 9, right, is still bigger than 2, and it doesn't matter which direction. The line is still going to be way steeper because the slope is so large. Does that make sense to everyone? For the most part. So then here's what we're normally going to see, right? They're going to just give us 2 points and ask us to calculate the slope. Okay. And so remember that I'm always trying to make this as easy as possible. It doesn't matter which one you call what, but like I said, I always kind of like to have my smaller values. So I'm going to call this X1, Y1, and then I'm going to call this X2. And I don't think they did it this way. No, they did it the opposite. Uh-huh. Yeah, no, it doesn't matter which, yeah, it still works either way. Just as long as you know you have your y2 minus y1 divided by x2. Yeah, yep, so it doesn't matter. And as you can see, yeah, they did it the opposite, right? They called this y2 and this one y1. And so then, right, once again, you do your subtraction first and then do your dividing. And so sometimes it's not really dividing, but just simplifying the fraction, right? Because 3/9 reduces to 1/3. So you want it as reduced or simplified as possible, okay? All right, everyone feeling okay with slope? Good. All right, let's practice. Okay. Let's just go ahead and I want you guys to at least get started on these practice questions. Read through them on your own, see if you can answer them. Okay. And then, so I'll give you guys the rest of class right now to kind of work on these 4 problems. And just do your best, see if it makes sense. If not, let me know, but I'll just give you guys this time to work. Number 2 is a little funky, but I just bear with it. But hopefully that one kind of makes sense. You can see what they're asking about. Don't worry too much about number 4 either. Can kind of be a bonus challenge question for those who are wanting that. Oh, yeah.
I'm familiar with the slopes and.
Sweet, good to know. We can progress quickly. Are you good with graphing and the other pieces?
Yeah.
Okay, good, good. You feel like you need to go faster, or is this helpful to review? Okay, yeah, no pressure. I just don't want you to feel like you're spinning wheels.
Next class, next week, right?
Yep.
For me?
Yep. Well, I mean, there's classes tomorrow too. So there's, I'm not sure what classes you were planning to attend, but there's math in the morning and then social studies at 1 o'clock, science at 4 o'clock. And yep, no class next Monday. Yep, yep, I know. Okay. Well, and I mean, you know, you're totally welcome to attend as much or as little class as you want to. We're kind of a little bit pre-algebra in the morning class compared to where we are here. So it might not be as useful. Yeah, of course. It's at 10. 10 to noon for math tomorrow. Okay. Sure. Yeah, of course. Yeah, you too. Hopefully work is easy. Yeah. I don't know. Sometimes busy days are nice, but sometimes people are hard. Curtis, Lauren, Faith, hopefully you guys are feeling okay about this stuff. Please let me know if you have any inputs. Okay. Kevin, I'll get the rest of those pages put together for you. The other thing you can do also is, all right, even though we have 5 minutes left, like I said, I don't really want to move too much further past this point. So if you guys are okay, if you could try your best to have questions 1, 2, and 3 ready to go to talk about on, well, actually, next Wednesday, because we don't have class on Monday. Monday's Labor Day, so hopefully and I'll send out a reminder, but yeah, so I would say let's just go ahead and try to have as much of page 27 ready to talk about and work on next Wednesday when we come back to class. And then we can move on from there, if that works for everyone. So, questions or comments or concerns? Does that work for everybody? So I know we're just working silently, but like I said, we're at such a good point. I don't want to add more or anything. So if that works for you guys, then we can just, well, I mean, I can stay on the Zoom call for another 3 minutes until class officially ends, but as long as you guys feel like you know what you need to do to prepare for our next class, it'll be on Wednesday, I think we can say we've done a good job. What do you guys think? So yeah, Tevin, I'll try and get the rest of those pages. I have to find the book. I think it's in this box. Should see if I can find it. All right. So,
study hour too, right?
Fridays, yep. Yep, you were more than welcome to join. And yeah, I can get you plugged in the online lessons and yeah.
So what's that for this space?
Mhm. Yep. Anything you want to do?